Good morning. This is Hope Reactor. Now, let's begin today's news.
An eraser does not actually erase writing. What if I told you that an eraser does not really erase pencil marks? Every day, students and workers use erasers without thinking about what is actually happening. You write something with a pencil. You make a mistake. You rub the paper with an eraser. The black mark disappears, and small pieces of eraser are left on the desk. It looks as if the writing simply vanished, but it did not. The graphite that formed the letters is still there. It has simply moved somewhere else. To understand this, we first need to look at how a pencil writes. Many people think pencil lead is made from lead metal. Modern pencils are actually made mainly from graphite and clay. Graphite is a form of carbon. When you move a pencil across paper, tiny pieces of graphite break away from the pencil core. Paper may look smooth, but under a microscope, its surface is full of fibers, gaps, and small irregularities. The graphite particles become trapped around these fibers. That collection of tiny black particles is what we see as a pencil line. The paper itself has not turned black. Graphite has simply attached itself to the surface, and that is exactly why an eraser can remove it. When you rub an eraser across pencil writing, friction helps loosen the graphite particles from the paper. At the same time, the material in the eraser has a stronger attraction to the graphite than the paper does. The graphite begins moving from the paper onto the surface of the eraser. So the eraser is not destroying the writing, it is collecting it. Imagine the paper holding thousands of tiny graphite particles. Then the eraser comes along and pulls many of those particles away. As more graphite leaves the paper, the pencil mark becomes lighter. Eventually, it becomes difficult for our eyes to see. But this creates another problem. If all the graphite sticks to the eraser, why does the eraser not become completely black and stop working after only a few uses? The answer is hidden in something most of us treat as garbage: eraser crumbs. When you rub an eraser against paper, the eraser itself is slowly worn away. The dirty outer surface containing graphite breaks off. Those pieces roll together and become the small crumbs left on the page or desk. This allows a cleaner layer of eraser material underneath to appear. The eraser is constantly removing its own dirty surface and exposing a fresh one. That is why it can continue picking up more graphite. In other words, an eraser works partly by sacrificing itself. Every time you erase something, a tiny part of the eraser disappears. Those annoying crumbs are actually evidence that the eraser is doing its job. They contain pieces of eraser material, together with graphite that once formed part of your writing. The next time you see eraser crumbs on your desk, you are looking at part of the sentence you just removed. But another question appears. Why does the paper survive? After all, you are rubbing it repeatedly with another material. The answer is that paper does not always survive perfectly. If you erase the same place too hard or too many times, the surface of the paper begins to change. The fibers can become rough. The paper may become thinner. Sometimes it can even tear. An eraser is not a magical machine that only recognizes graphite. Its material is designed to remove graphite efficiently, while causing relatively little damage to paper when used normally. That balance is one reason modern erasers work so well. And now we reach an even more familiar mystery. Why can ordinary pencil marks be erased quite easily, while colored pencil marks are often much harder to remove? The difference is not simply the color. The materials are different. A normal graphite pencil mainly uses graphite and clay. Colored pencils use pigments to create color, but they also commonly contain substances such as waxes or oils that help the pigment move smoothly across paper. When you draw with a colored pencil, these materials can become strongly embedded in and around the paper fibers. An ordinary eraser can remove some of them, but it is much harder to pull everything back out. That is why colored pencil marks often remain visible, even after repeated erasing. The difference between a pencil that erases easily and one that does not is partly a story of material science. What is attached to the paper? How strongly is it attached? How deeply has it entered the paper fibers? And what material is being used to remove it? These questions determine how easily a mark disappears. The history of erasing is also surprisingly interesting. Before modern erasers became common, people used other materials to remove graphite marks. One famous example is soft bread. Pieces of bread could be pressed and rubbed against graphite to lift, some of it from paper. Imagine sitting in a classroom today and hearing someone say that they made a mistake and need a piece of bread. It sounds strange now, but the basic idea was similar. use a soft material that can pick up graphite from the surface of the paper. Later, rubber became associated with removing pencil marks, and eraser materials continued to improve. Today, many erasers are made from synthetic rubber or plastic-based materials. Manufacturers adjust softness, friction, strength, and other properties, so an eraser can remove graphite effectively without damaging the paper too much. This is why something as simple as an eraser is actually a carefully designed tool. It combines the properties of graphite, paper, friction, adhesion, and flexible materials. And all of that science fits inside an object, small enough to sit next to your pencil. We often imagine technology as something futuristic. Artificial intelligence, robots, spacecraft, advanced batteries. But technology is also hidden inside ordinary objects that have become so familiar that we stop noticing them. A pencil lets us put an idea onto paper. An eraser lets us change that idea. Write, make a mistake, remove it, try again. That simple cycle is possible because tiny graphite particles can be transferred from one material to another. So the next time you erase a word, look at the crumbs left behind. They are not just waste. They are pieces of the eraser mixed with graphite. That used to be part of your writing. The words did not disappear. They were moved. Sometimes the most interesting science is not hidden in a laboratory. It is already sitting on your desk. Something you have used hundreds of times can still contain a story you never knew, because what we do not know today can become the spark for what we discover tomorrow. Hope Reactor.